Welcome all you to the final presentations on tunneling with GTS NX. Today our prime focus will be to study the effect on tunneling on nearby structures. If you will agree with metro stations or with the tunnels coming under the cities which are already developed, one of the prime concern nowadays is how exactly the tunnel is going to affect our nearby structure. So is true for the other case round. Let's suppose there is already existing building and we are going to create some superstructure nearby. So what is the effect of the same? So I will show you modeling for one where we have an already existing structure and we are going to do tunneling after that. So this is how the model will look like. We're considering 3 piers of a bridge maybe with piles, and then we have a tunnel. Well, we'll consider the construction stage here, as you already seen that it's very important to consider the same. So this is how our construction stage basically will be looking like: existing building, and then we are doing the construction. Please note that it's a continuum model and you have a soil around. Just to show you the construction definition, I have just hide the soil mass around it. Fine. So today we'll also take into the problem one very important function: change property with the help of a boundary condition. So I will explain it to you during the demonstration basically. Now today basically we'll be mostly working in the software. How exactly? We'll start from the basic. I'm not going to import anything. So I will appreciate your patience, and even you will understand that how one can use completely the GTS NX platform to create any complex geometry. So moving on to the program now. Fine. So let me just say a new project. So initially you need to select what kind of project you want to do. Its model type is 3D, 2D or axisymmetric. For us it's 3D. Say OK. Fine. So first thing which I want to do is, I will just start with the superstructure part. First thing is I will adjust my work plane. As you already know that all the 2D commands are going to work in the work plane. So we must decide efficiently that which work plane we are going to use, say XY. So I'm starting with the superstructure first, which is the pier foundation for the bridge in our case. Okay. So let's suppose the value is 6,3 for the base rectangle. So I'm just going to rectangle, say 0, 0 and apply, and 6, 3. Fine. Just going to isometric view. Okay. Let us consider the circular pier. So I'm just creating a circle, 6, input location is 3, 1.5, be it at center. Input radius is 1 meter. Say OK. Fine. I'm creating two rectangles. Now these rectangles are basically for the top part of the pier. Now why I'm creating here itself, because my working place is XY. I'll create it and I will translate it. Fine. So different person can have different way of modeling. For me, I just create everything on the XY plane, whichever working plane, and then use the translate and extrude command to move it at different location. Okay. So it can vary. You can use other commands as well. So first is basically again a rectangle. I'm just inputting the coordinates as follows. Just a second. There are some coordinates. We can, even if you want to put, you can just use a rectangle like that in the working plane. Just let me show you another way. So let's create a rectangle. Okay. Now I want to just create a rectangle such that encloses my circle. Fine. So I can input some value, or I can just create by clicking in the, because my work plane is XY, right? So you can use any point and you can create that rectangle as well. It depends completely on you, but since you will be dealing with actual geometric thing, so you need to have proper coordinates so that you enclose it completely. Fine. So let me just, and I need one more rectangle for the top solid. So what I'm doing is I'm just scaling it down. I'm using this rectangle only. I'm using the scale function. So one more command which you can see that how exactly it can be used. So scale. So what is your target object? So let's say this rectangle. Scale center. I'm keeping the center of the rectangle, say 3, 1.5, 0. And I'm making a non-uniform copy. Let's suppose in the X I'm making it 1.2 times and the Y 0.7. This is the top part of my bridge pier basically. Copy the foundation, preview it, looks good enough. Okay, say okay. So this is how you can scale and create. Then I need to create a rectangle. It's more like a square, which will be basically the base part of the top part of the superstructure. So let us input the values, the coordinates basically. So I'm just next let us just create the another rectangle, so 0, 0. We'll say the input as 1.95, 0.45, and then we have relative length of 2.1, 2.1. Fine. So the coordinates are already determined by me. So everything I have created in the same work plane. Fine. Now let us use the extrude command. So extrude, say basic. I'm using the rectangle. This is basically for the raft part of the superstructure. Preview it, say 1.2 meter, and I'm just naming it as pier raft. Sorry, just naming it at the geometric set, say pier raft, say apply. Fine. Similarly, I'm using the edge, selecting the circle, select the direction. Okay, I'm just saving the file in a new folder. Save it. So select the direction selected. Let's say in the upward direction a length of 8 meters. Preview it. Can say it as pier column. Fine. So just going to isometric view, say apply. Then you go to select target object, say basic again. Now we don't want to extrude basically. Now I'm going to geometry, I'm going to translate. Select the target object, say basic. This is the bottom part. So I'll translate it at length of, let's say, 8 meters. Preview it. Fine. So apply. Similarly, select the target object, making it basic again, select the direction, and I'm moving it by 8.8. Preview and say OK. Fine. Now I just want to create a solid out of two ways. Okay, there may be many functions, but I would like to show you one function where you just create the surface and you can sew them into solid. Okay, so you go to line. Now as you know that line will always work in the work plane in which you are working when it's 2D. So you can click on 3D. Okay, now I'm selecting these edges and I'm just connecting them. Fine. So the 3D line can be used to create it. But still now it's only a wire frame, right? Now let us use the face command. Make face, select the faces, say apply. Okay, similarly you can do for other parts. I'll quickly do it over here. So I'm just showing you everything so that you can understand how easy it is to create it over here itself. Say apply. Now the bottom 4, this part, and finally you have. So for example, if you are bringing any DXF 3D wireframe into the program, you can use make face to create all the faces such that an enclosed figure, of course, remember that it should be an enclosed figure. Okay, now I'm going to front view. Then there is a command in Boolean surface. Okay, and there you have the options shoe. So you can merge all the faces and make a solid out of it. Okay, many times you will be requiring it, especially if you are importing a DXF file. So easily, when you just say delete original, merge face and make solid, select all the solids, make sure that it is an enclosed figure, which is true in our case, just say OK. Now you have 3 solids, right? Now this is basically nothing but a solid, even the top part. Okay, now I'll just extrude it. Say extrude face. So I'm selecting the top face, select the direction, let's say length of 1 meters, preview it and just say OK. Fine. So this is a basic model. So let us do few modification using the Boolean operation, selecting the top 2 solids and merging into one. Fine. So this is one solid, then you have the pier column and finally the pier raft. Fine. Now just going to tools and just saying change the color so that I can differentiate. So random color for the 3 solids and just say apply. Fine. Now next what we have to create is we need to create the piles. Okay. So right now we just used the line command, right? So 2D will be only working in the work plane. I can directly use the 3D if I just know the coordinates, and I can, so even if I create one pile, then I can use the translate command to move it to a different location to just make a copy. So now let us use 3D. So first coordinates, let's suppose it is at 1, 0.75. So you can just first calculate it, draw a rough sketch so that you get a rough idea of where exactly you want to place. Then 0. Not 0, I will just start at the bottom of the raft. So minus 1.2 and 0, 0. Let's say it's an 8-meter long pile. Fine. So this is your first pile. Now you can simply use the command like translate, select the target object, select the direction, copy, let's say at a distance of 2 meters and 2 times. Preview it, say apply. You can just keep it in the geometry stage group piles, say apply. Select the target object, select this, 3, select the direction. So distance of 1.75 and number of times, sorry, it's just 0.75. I can think we can keep it 1.5 so that, and number of times is just 1 so that we can place it symmetrically. Fine, say OK. Fine. Now always remember that whenever you have curves, always try to imprint it, because you know that the stress transfer will be proper only when you have node to node connection, correct? So GTS NX provides you with the option of imprint. Even you have imprint auto, which I already have demonstrated, but let me show a simple how to imprint without using the auto command. Select the target object, which is your face. Select the tool object. I'm going to front view, select by intersection. This is my tool objects. Direction of shortest path, it will automatically draw a normal. So it's, since both are connected, say OK. So you can see there is a node connected. So whatever mesh size you are going to give to the pile raft, it will always create a node where exactly the piles are there. Fine. So this is basically our superstructure. Okay. So we use simple commands like we created a rectangle, we extruded it, we translated it, and we use the lines to create the piles. Okay. So hope it was clear. Now basically I just want to make a copy. So translate, select the target object. So I'm just making it first. Select by rectangular, select all, select the direction, copy, distance let's say 20 meters, number of times being 2. Preview it and just say OK. Fine, good enough for the superstructure part. Now let us come to the soil part. I'm going to the front view. Fine, now I'm just zooming out a bit so that I can move my work plane to XZ now. Okay, now I'm creating a rectangle which will be for my soil mass. Fine. Now this is the rectangle which we'll be using to create the main soil mass. Next we need our tunnel. Now let us determine some locations. So let it be at a distance of 8 meter from origin I'm talking, and minus 16 meters since the length of the pile is already 8 plus 1.2 9.2. So I'm just taking a distance between both of them as almost 6.8. Okay, so this is my coordinate, and let's suppose the dia of the circular tunnel be 1.2. Fine. So this is your tunnel location. Now we have to simply use the extrude command. So extrude, select the target object basic, select the direction, let it be 60 meters, preview it. You can name the geometry set as main ground and say apply. Similarly, to extrude the tunnel, just select the tunnel edge, select the direction 60 meters again, preview it and name it as tunnel. Say OK. Fine. Now I just want my tunnel and solid in the other direction, because we have just started from the XZ plane, all in the positive direction, but we cannot just start the model from here. I just wanted some soil mass at front also. So first I will just perform the auto connect. Say Boolean, select all and just say OK. Fine. So now these two solids are independent. Now let's say extrude again. Say basic, and I'm just selecting the outer rectangle for the soil mass. Let's suppose 15 meters in the reverse direction. Selecting the main ground mesh set again. So preview it, say apply. Fine. So if you want to merge these two solids into one, you go to solid Boolean operation, fuse, select both the solids and just select the option merge the face. Delete the tool means both the solids will be deleted and there will be only one solid. Just say OK. Fine. Now this is one single solid, right? You can just select and say height. Now we will extrude the tunnel part as well. Say face. So you can select this face, select direction. Once again 15 meters. Reverse the direction, preview it. And again tunnel and say OK. Once again, we'll just fuse it. So solid fuse, select both the solids, merge the face and delete the tools. Okay. Fine. So we are done with our geometric modeling. So if you see that any complex simple geometry can be easily modeled with all the geometric modeling commands in the software itself. Okay. Now we'll just perform one final auto connect because of the two new solids created. Select all and just say OK. Fine. So the basic geometric modeling is done. Now we have to take care of the construction stage analysis of the tunnel. So we have to divide the tunnel solid into desired lengths. Okay. Once again, front view. Please remember that our work plane is at this part where we just the face from which we extruded. So whatever you are going to create will be created at that phase. So not a difficulty. When you have commands like translate, you can translate in both the direction. So I'm using the same work plane, rectangle, make face. This is, I think, pretty much clear with our previous sessions. Now you say translate. Select the target object, which is the face. Select the direction. First I'm moving in this, and then I can translate it in the other direction. Make a copy, let's say 5 meter. I know it's a big, but just for demonstration purpose. Number of times being 12. Since the total length is 60. Fine, good enough. Say apply. Similarly, select the target object, select the direction. This time negative. The other direction, not 12 times, 3 times will do. Preview it and just say OK. Fine. Then solid divide. Select the target solid. Done. Select the tool surface. Now you can do it manually, or you can just go to front view and use the command like select by intersection. Fine. So I've just intersected only the faces of the dividing tools. Delete the original. Yes, we don't want it. Delete the tools. Not needed the faces after the performance. Just say OK. Done. Fine. So once again, I'm just opening and I'm just doing the auto connect, because the first Boolean operation which we performed using the auto connect was with the main soil and one single solid tunnel. But now we have divided it into 15 new solids. So we have to perform the Boolean operations. Okay. Select all and say OK. Fine, done. Now, next thing is, till now we have always dealt with a homogeneous layer. So I just want to show you, let's suppose we have two layers. How can you model it? Different ways to model it. First, let's suppose, just for example, you have a soil layer beneath this. So you can use the extrude command. You can select, let's suppose, you can use the extrude command. Select the face here. I'm just selected by single or rectangle. Select the direction and then say preview. This is how you can create the solids. The other way around is, for example, I just want to divide it into two parts. So if you remember, to divide any solid, what you need is a tool surface. Okay, so I can create the tool surface. I can go to make face. I'm just selecting this 4 faces. Preview it. Fine, just say OK. Fine. So you have one surface created. Now you can translate it. Just make it face. Select the direction. Let's say copy. And let's suppose at a distance of -10. Preview it. Just say OK. Now if you just say solid divide. Select the target solid. If I can just hide all the other solids so that I can select the face. Fine. Select the tool face. Done. Preview it and just say OK. Now I will just check on all the solids. So you can see it's divided now. I can hide the surface from here. So auto connect. Select all and just say OK. So whenever you want to check whether all the solids are connected or not, you can always go to check duplicate and say apply. So if two solids are connected, they should share a common face, right? So that is what this orange face is representing here. Okay, so all the solids which are sharing a common face with the other solid are properly connected, and whatever mesh size you give it to them, the program is going to take care of the nodal connectivity. Fine. So close it. So this is all from the geometric modeling part. Now we will move on to the material definition as well as the property definition. So you go to mesh, material, create isotropic. So we have two layers of soil, right? So more column. I'm naming the first layer as layer 1. So I'm keeping the default parameters for layer 1. Say apply. Layer 2. I'm increasing the cohesion, let's say 150. Friction angle, let's suppose, let it be 36, and I'm increasing the E value to 500,000. Okay, say apply. Then I'm using elastic concrete for basically all my piles and the superstructure. I'm using the same grade of concrete. If you have different grade, of course, there will be a difference. So you can define different grades of concrete separately. Fine. So just giving it a name, concrete. Say OK. So these are the material properties. Now let us talk about the various types of properties which we need to define. So what all we have, first off, let us start with 3D, which is clearly visible directly. Layer 1, of course, the soil mass, say apply. Then you have layer 2, say apply. Then you have concrete, so I can use it for raft or the superstructure, which are basically model solid. So I can just give it a name, concrete, say OK. Fine. Now there are two other things. If you see, first is the shell element, which will be basically supporting our tunnel. Let us give some thickness 0.3 and name it as shotcrete. Say OK. And finally we have the 1D elements, which are the piles, right? So I'm just defining it as embedded beam, giving it a circular section, let's say dia of 0.6 meters, and naming it as piles. Say OK. Close it. Now let us start meshing it. So first of all, let us start with the smaller solids, which are our area of concern, right? So mesh, 3D mesh. I'd like your kind attention from here that how exactly we are assigning the properties. First of all, I'm just selecting the solid Raft. Okay, only the bottom one. Okay, and I'm giving it a property of layer 1. Why exactly is because when I'm creating the first stage, I want everything as in situ, inside condition, right? So I'm just giving it a soil property. Later on, I will change the property of this soil to concrete using the change property option, which I just demonstrated. Anyways, I will explain it to you. Okay, so layer 1, please remember, and I'm naming it as Raft so that I know that which mesh set is which one. Okay, so very important that you name it correctly. So I'm giving it a mesh size, let's say 0.5, and say apply. I'm just doing undo for now so that let me just undo for now so that I can basically use the hybrid measure instead of tetra. So select the 3, giving it a size of 0.5. Hybrid measure. Once again, please check that the property right now assigned to them is of layer 1. Say Raft, apply. Fine, the meshing is done. Now I can mesh the above solids. Since they are going to be activated as a material of concrete, I'm just giving it name pier superstructure so that I can understand which all to activate. When defining the construction stage, mesh size of 0.5, again hybrid measure, say apply. Fine. Now after meshing this, I go to the tunnels, just selecting all, giving same size of 0.5. Now since it's in layer 2, I am giving it the property of layer 2, and I'm just giving it name EX, standing for excavation. Anyways, I will rename it, just say apply. Hope everything clear till now. Okay, now we have to rename it, but let's extract the shotcrete as well. So before using the extract command, you know that we have to mesh all the solids first. Fine, so mesh, 3D mesh. I'm just selecting this top solid, giving it a size of, let's say, 2. Hybrid measure, of course, layer 1, and naming it as layer 1. say apply. So please note that many times what's the use of change property option is. Let's suppose even if for your shotcrete, right, it is having it doesn't gain the actual concrete properties at the initial stage itself. So you can use the change boundary condition to change the property at any point of time. For example, you just want to assign some property at initial stage and you want to change it later on. Okay, because while meshing you can assign only one type of property to any solid or any element. That's why it's very important to understand that change property is a very helpful tool whenever you are dealing with the construction stage analysis. It's taking some time, just aborting to quicken up the process and just increase the mesh size. So hybrid mesher do take some time to mesh, but if you will find that as compared to tetra mesher, the number of elements created in the hybrid mesh is very much less. So it gives you dual advantage also. First of all, more symmetrical results, and as well as the analysis time is also less because the number of elements as compared to the tetra mesher is less. Okay, but it do take some time to create all the elements because it's basically creating the basic element as hexahedron, right? So that's why. So again, so similarly for layer 2, just name it layer 2 and just say apply. As mentioned, so once you take care of the check duplicate or once in the solid modeling option, you need not take care of the nodal connectivity, whatever mesh size you give. For example, I gave 0.5 for the superstructure, I gave 0.5 for the tunnels, and I'm giving the outer solids a size of 4. So the program will take care of the nodal connectivity. Even if you give a size of 10, it will take care of the nodal connection, and hence you will see a deviation from larger elements towards the outer edge where they are basically not required to finer towards the tunnels or towards the raft in this case, which are your area of concern. Okay, so there you will find a finer mesh, of course. Okay, so the program takes care of that, but you must make sure that the check duplicate or the auto connect basically or the orange face is existing between the solid before you move on to this phase. Fine. So if I just zoom in, I'm just hiding all the geometry. So you can say that the node to node connection has been taken care by the program. Fine. Now this is how our model looks like. Now I'm closing it. Now a few things which are remaining is the shotcrete and the meshing of piles. So let's hide everything and activate only the solids. Fine. Now you can use extract from face, select all. So going to unselect mode and unselect by intersection. So I'm going to front view. I'm unselecting all the faces which are shared in between the solids, registered based on owner shape, and name it as shotcrete. Say OK. If you hide the solids, you can have a look. I'm sorry, a few unwanted face got unselected. I'm just saying Control Z again. Select by intersection, just say height. So extract, say face, select all. I'm giving it a name shotcrete. Going to the unselect mode. So maybe while intersecting, I intersected one of the outside faces. So just to check, you can just rotate it. Looks good to me now. Fine. Now just say OK. Still to make sure I can see a complete shotcrete now. Fine. So this is how you are going to create. Now the next important thing is still we have not meshed our piles. Fine. So I'm going to just the front view. Now I can mesh all of them at once because I'll be activating all of them in a single stage. So select the object. So select the intersection. Check on the selection mode. 10 and name as piles. Say OK. Fine. So even if I just want to check the property, so you can check how exactly they look like. And similarly for the shotcrete. Fine. So the meshing part is done. Now let us come to the boundary conditions. Okay, here there will be few new boundary conditions which will be used. So let us first hide the solids. Fine. First is basically for the piles. You go to static slope analysis. You go to constraint. So in the advanced, basically we need to select all the nodes. So first of all, I am hiding the shotcrete for easy selection of the piles. Fine. Now I'm just saying select all. With all the piles activated, we need to restrain them in the RZ direction. Okay, for the rotation in the Z direction. Seems we have one pile less over there. Let me just check once. If I select all the piles, maybe because of the naming few piles didn't came. Let me just create one pile. Maybe because of translating, I missed few piles. I'm just saying Control Z undo. As I can see only 5 piles over here. I'll just create one pile so as to maintain the symmetry. So I'm just giving the coordinates as 1, 0.75, minus 1.2 and length of 8 meters. Now just to make sure that it's imprinted, we already imprinted it, so I'll just mesh it. If you see at the bottom, I'll just activate the solid. So it's already imprinted, so no need to imprint it again. So mesh, 1D mesh, selected the 18 here. You can check the number, it will be good when you mesh. So pile, say OK. Fine. Now I'm hiding all the geometry, only the piles. So first boundary condition is basically restraining all the piles in the RZ direction. So select all RZ and you can give it a name. Always give it a name to understand what exactly a particular boundary set means. Say OK, pile constraint done. Then the next is, if you remember still the raft, they are having the properties of soil, right? So what I want to do is at a later stage, I want to change the property to concrete. Okay. So first stage it's layer. So how to change that? In the boundary option, there is an option called change property. Since we are going by construction stage, you can select that. Say select all. So now the property will be changed to concrete. Okay, so a boundary condition will be created. So whenever you activate that, it will imply that the property has changed to concrete. So just say OK. So as you know, you can go to analysis. There you have the 3 boundary conditions for the 3 rafts. Okay, so whenever you activate this, will mean that the property has changed to concrete. So good enough for this. Now we have the general support condition. So constraint, you can go to auto, name it as GS, standing for ground support, just say OK. Self weight as W. Okay. Now let's suppose you want to apply some load on the on the bridge pair coming from the foundation. I'm just taking few nodes by select by single. Okay, so let's suppose I'm selecting 3 nodes on each of the pier. Giving it a value of, let's say, minus 3000 and say pressure. Preview it and just say OK. Fine. So this is basically our complete modeling. Fine. Now we'll come to the construction stage definition. Now you will agree with me on the fact that the construction stage definition for almost 15 solids, if done manually, will be pretty much difficult, right? So we'll be going to use the stage definition wizard. For that, first thing which should make sure is that the naming is proper. So mesh, first for the excavation, say rename, select all, direction will be Y, and give it a name excavation. So automatically it will name. Fine. Similarly, I'm hiding it, and you can go to shotcrete. So rename. So select all, say Y direction again, and naming it as shotcrete. Say OK. Fine. Now we can go to static slope analysis. There you have the stage wizard. Please note that what I am doing is I'm just using the stage definition wizard, especially for those parts where there is basically a repetition, okay, where you can basically for the excavation and activation of the shotcrete. So mesh set, first is excavation, okay. So what we are going to do, we are going to remove it, and I'm starting from stage 2. Why, I will tell you. So we have 1, and total number, if you can see from the left hand side, it says 15, correct? So the last is 15. Increment will be of 1, but the start stage is 2. Fine. Similarly, mesh set, this time we are going for shotcrete. Activation, so 1 to 15 again, and the shotcrete will be activated one stage after the excavation. Fine. So apply the assignment rules. Now you can activate for the initial stage excavation, no need for the shotcrete layers, okay, ground support condition, and self weight. Fine. Now just give it a name, say add. Fine. Apply assignment rules. I'm just activating for the initial stage. So we'll modify it after we go to if the basic definition after stage 2 is done, we can do manual changes, of course. So layer 1, ground support condition, okay, just say okay. Even the rafts, for now I'm just saying okay. So basically my big task is done, but I have to do few changes to make myself understand the first few stages, okay. Now first stage, if you remember, you have everything activated, okay, but there is also the raft, the 3 rafts which are having the soil properties, correct? So you have let's see simultaneously what we are going to activate, so that it gives a clear picture of what basically we are doing, okay. So I'm just moving it onto the right hand side a bit. So first stage, if I just say activate, so see the whole soil mass is activate, all excavation, even this part. Now next stage I have just kept empty for myself, okay. Now first stage needs few changes. Clear displacement, I already explained. We just don't want to see any displacement because of the load. We just want to initialize the stress. Move on to the second stage. Now second stage, what I want to do is I want to activate I'm considering that this bridge is existing for a long period of time, and whatever settlement that was going to happen has already taken place. Okay. First of all, let's activate the superstructures. Clear? Now please remember that the raft is still having the property of soil. So what I am doing is activating these three boundary conditions. What it does is it's changing the property to concrete. Superstructure done. Then we have the piles, and once again the pile constraint which comes along with the pile. Then you have the pressure load. Okay. Now this stage you can see the settlement coming because on the settlement happening because of this pressure load and this bridge foundation. But what the motto of my project now is to consider the effect of tunneling. So I'm expecting, or I am thinking that this bridge foundation has already existing. So whatever settlement that was going to happen has already taken place. So I'm just clearing the displacement. Okay. Now you might be thinking, what's the importance of modeling it? The importance of modeling the superstructure here is basically what stress changes in the model has happened due to the existence of this superstructure and load will be considered with the help of this stage. Fine. Then you have, if I can just hide it from here, layer 1 and layer 2 so that you can see inside the model now. Okay. Then if we see, fine. So layer 1, and similarly you have one stage after the excavation, the shotcrete. So you can do it as you want, the construction stage definition. Fine. So just close it. Now you can go to analysis. You can go to general, construction stage, select the stage for the stress analysis and just say OK. Then you can perform the analysis. Okay. So since the analysis is going to take some time, I have already one model analyzed for the demonstration part. Okay. Now let us go to the results part. So with each stage you can see that what exactly. So in the second stage the program is not going to show you any displacement. Okay. Because in the second stage means S1 I mean. Okay. So no displacement, because what here the program is considering is only if you want to see the stress, you can see the stress variation as a result of your activation or application of the load. Fine. Then we come to the next stage where you start the excavation part. Let me just hide the boundary condition so that we can see inside the model. Fine. So this is Tx. Okay. Now we want to see that what is the influence basically on our foundation, right? How exactly it is going to affect the tunneling. Fine. Now let us have a look at the same. So with each stage you can see that how exactly the effect is going to happen. Okay. Now let us go to stage 5, let's say. So Tx I am showing you. Fine. So if you see till Tx till stage 5, there is hardly any effect on the foundation. So, and as you move on, so you can see the effects coming on. Now I can just use this to show you. It's like constructions. So after few stages you can see the effect coming on the first foundation. Maybe the effect is not too much. Let's just probe the value. It's somewhere around in millimeters if I say. So 0.36. Then I move. You can see the influence has now reached the second foundation, and finally you have the last bridge pier. Fine. So this is how you can simulate the stage. Even let's just extract a value. For example, I'm interested to see displacement for the top part. I'm just selecting. You can even select any foundation node. So I'm selecting one node from each of the bridge pier and just say table. So these are the values, correct? I just say show graph, default serial number, say okay. So you can see here which stage that at which stage basically the influence has coming to start, and at which what is the maximum value after which it has just become constant for each of the P. Similarly, if you can say Tx, which you are interested in, the horizontal displacement, same steps. Just say table, say right click, so graph, default serial numbers, and just say OK. So here also you can see the influence directly. Okay. So even if you want to check what is the change in the axial force of the pile, what is the settlement happening, we have already checked for the settlement. Okay, how exactly it is going to behave for the shotcrete with each step can be checked and analyzed for. Okay, so this is how basically one can study the effect of tunneling on nearby structure. This was a simple model where we have a circular tunnel and a soil layer with a high E value. Okay, and we want to see with each stage how exactly, if there is some existing structure, in this case a bridge pier foundation, but maybe some building, and you are performing the tunnel, how exactly it can affect and effect in terms of settlement stresses in the piles. Okay, even if you want to see the pile deformation, just the amplified version I would like to show you. Say pile, going to deformed shape now. So you can see that how exactly, because of the tunneling, the piles are basically dragged towards them. It's an amplified, not a big value. If you see, if I just probe it, it's TZ, right? And let me show you TX. Okay, so it's hardly 0.0653, but you can see the effect of the tunneling onto the piles and onto the superstructure. So that's all from my side. Hope I was able to give you a brief idea of how GTS NX can be used for various applications of geotechnical, especially tunneling, what we have dealt in our last 4 sessions. So I tried to mostly use all the geometric commands in the software itself, try to build up complex geometry and show you the various features available in GTS NX, which makes it a tool good enough for handling the tunnel models very easily and efficiently. So that's all from my side. Thank you very much for having your time to attend the sessions. So thank you very much.